Once again, to try to evaluate this limit, you begin by just trying to plug in that x equals 3. Maybe the direct substitution property works, but it doesn't, yet again. On top, you get the square root of 4 minus 2, and that's equal to 0. And on bottom, you get 3 minus 3, and that's equal to 0. So what's actually going to happen here whenever you see one of these expressions where there's a square root somewhere is we're actually going to multiply by the conjugate. So the conjugate is a very broad general term. It's used for complex numbers. It's also used for expressions that have radicals in them. Whenever you see two terms like this, the conjugate will be this exact expression, but the minus will be turned into a plus, and if there were a plus, it would be turned into a minus. So these two expressions, radical x plus 1 minus 2 and radical x plus 1 plus 2, they are conjugates of each other. And so a general technique that you'll learn is that you can always multiply on top and bottom by that conjugate. You notice how that doesn't change the fraction because you're multiplying by 1. That will actually get rid of that radical on top, and it will make some cool things happen. So now I need to simplify this thing. And I'm going to do two different things. One, I am going to multiply those conjugates together. And notice how if you have the square root of x plus 1 and you square that, the radical and the square are going to go away, and you're going to be left with just x plus 1. And then you have 2 squared. So you have a plus b times a minus b is equal to a squared minus b squared. That's exactly what's reflected here. On bottom, I've simply concatenated these two expressions. I've just smashed them next to each other, but I'm not going to do anything else to them. Just leave them alone. Next, I'm going to do the obvious thing, and I'm going to combine the x plus 1 and the minus 4. And now you can see that I have a rational expression where there's a factor in common on top and bottom, and so I'm going to use my handy cancellation property. I'm doing a limit, therefore I'm allowed to cancel the x minus 3's. And this is what I have left, 1 over radical x plus 1 plus 2. This is fantastic because if I try to substitute the x equals 3 again, I actually get a number. And so this is the moment, yet again, this is the moment when the limit actually gets done. LIM x arrow 3 does its thing to this expression and literally turns it into the number 1 over 4.